Hi, my name is Orla Cullen, and in this video I'll be demonstrating the critical capabilities and features in SAP Analytics Cloud. For continuity, we have grouped these demonstrations by product area. Smart Discovery is an automated data exploration capability in SAP Analytics Cloud. Smart Discovery allows a business user to apply machine learning directly to BI data without additional data preparation steps. A user can specify a business question, and Smart Discovery helps them understand their data in the context of that question. We have made significant enhancements to Smart Discovery over the past 12 months, including automatic data preparation, redesigning the overview page to provide a clearer answer to the business question the user has asked, and finally, we've also redesigned the Key Influencers page to better help users understand what is driving their data. When launching Smart Discovery, the user specifies the question by selecting the target and the entity. Here, the business user wants to understand more about what is driving revenue for each sales opportunity. Therefore, the target will be weighted revenue, and the entity to analyze it by is opportunity. There are options for advanced settings and filters in order to refine your business question. For example, the dataset could optionally be filtered to focus on a subset of the data. The user can also exclude specific measures or dimensions from the exploration. In this case, we will use the full dataset. Smart Discovery Automated Exploration is powered by a combination of analysis based on both predictive analytics and statistical analysis. The process automatically builds a predictive model to predict the target and the insights provided on the key influencers, unexpected values, and simulation pages. In order to build the predictive model, the data is prepared automatically by Smart Discovery. The generated content contains an overview page that provides a statistical analysis of the data. The appropriate visualization is selected based on the data. In this example, we have a KPI with variance shown as the model contains both an actual and planning version of the data, a histogram to show the distribution of gross margin in the dataset, and a time series chart. The decision on which variables to show and which visualizations to use are based on the data and will change for different use cases. The generated story also identifies the key influencers or key drivers, which are variables in the dataset that have a strong relationship on the target. These key drivers are derived from the automatic predictive model, which is generated using our automated predictive library. A description of the relationship for each influencer to the target and relationships between variables or correlations are explained in natural language. These correlations can help show hidden rules or biases in the data. The quality of the underlying model is clearly presented and explained, as this allows the user to determine if it is safe to make decisions based on this analysis. A natural language summary of the key influencers ensures the user interprets the chart correctly. A clear description of the automated data preparation is also provided. Visualizations below are generated for the most significant influencer and a combination of the two most significant influencers. Users can also easily select and combine other influencers to understand the impact on their data. On the Unexpected Values tab, we are presented with outliers detected within our data. We build a predictive model to predict the target values, and the outliers are data points that differ significantly from the underlying pattern in the data, yet providing more insight. The simulation page allows users to perform what-if analysis by synthesizing a row of data and using the generated predictive model to predict the target for these new values. In this example, we changed the campaign type from 9 to 12. And we will indeed see an overall positive impact in the opportunity value. The generated text is automatically generated and reflects the dataset and the business user's question. SAP Analytics Cloud automatically generates written content through Smart Insights. A Smart Insights dynamic text token can be embedded directly into a visualization, or alternatively, Smart Insights can be triggered directly from any data point in any visualization. When we launch Smart Insights, insights are provided in the side panel and explained using a combination of generated natural language and visualizations. The most appropriate chart is selected automatically for each insight. The first insight provided explains how the selected measure has changed over time. The insight is explained in natural language and a time series chart with the variance is generated. This explains recent changes in the measure, allowing the user to see if the current value is typical over time and to see any unexpected changes. The most interesting time level in the hierarchy is selected by default, but the user can easily switch between these levels. We can also see what is driving the value of gross margin. Smart Insights identifies the top contributors. These are the key drivers or dimensions which have the most significant contribution to the selected value. Again, the insights are presented using a simple natural language explanation and the most appropriate chart type. I can drill down on an insight in order to get a better understanding of what drives the gross margin for that subselection of the data. The progressive disclosure model allows the user to explore their insights based on their business needs. The smart insights provided are personalized for the user, as the insights are always relevant to the user's context. They are based on the current visualization, taking into account any selection the user has made or any filters they may have applied. The generated output text and chart text are supported in the wide selection of languages available in SAP Analytics Cloud. Additionally, data change insights can also be pushed on a subscription basis using SAP Analytics Cloud. Here, a user can pick the KPI of their choosing and subscribe to a KPI, indicating thresholds of interest. If such a threshold is met, the user will proactively receive a notification with the report embedded to always stay up to date on their most important KPIs. Here we will illustrate SAP Analytics Cloud's ability to perform smart grouping or clustering. Smart grouping or clustering can be applied to correlation-related charts like bubble charts or scatter plots. With the flick of a switch, the business user can create statistically homogeneous groups. The user can then decide how many groups they would like to explain the homogeneous groups that we see here on the screen. The color coding will be overwritten using smart grouping, giving a clear overview of these groups. Forecasting is an integral part of analytics and planning. Forecasts can even be added directly from the context menu for an analytical user. Here we can see in a time series chart that a user can add a forecast directly, choosing from simple options like an automatic forecast or even advanced options that take into account things like seasonality. Picking one of these advanced options shows us that a forecast has been added. The end user can use the forecast directly within his planning operations and can now analyse how accurate the forecast is using mean average percentage error, showing us the upper and lower confidence ranges, aiding the business user in their decision making. Taking the business forecasting capability one step further, SAP Analytics Cloud is uniquely positioned to combine the world of analytical insight with the world of decision making using the planning capability. To illustrate this, we'll show you this directly from the table as before. Using the contextual menu, we can create a predictive forecast. The difference being that here we can use those same algorithms as shown before in the chart, but the results can be written back directly into the model. Further capabilities of SAP Analytics Cloud include the ability to create a predictive model per data slice. For example, in this case, by region and by product. And we'll look at that in Smart Predict. Smart Predict is actually able to create a predictive model for each of these data slices. So let's make a prediction for the subsequent quarters for gross revenue by region and by product. Smart Predict is business focused, meaning we only have to select the model, the version that we want to base our model predictions on, the target that we want to predict, in this case gross revenue. We'll need to select the time dimension and the number of forecasts we want to deliver, so in this case 9 months to complete the year. Furthermore, we want to select the data slices by using the entity. And here we select byte type, as well as region. Finally, we choose a window frame of what type of observation we'd like to use, and even a new functionality, the capability to add additional measures that could function as influencers. So using our business knowledge to potentially make the model more accurate. We now choose to train and forecast the model. Whilst we are doing this, the product in the background is training individual models for each and every data slice, potentially creating thousands and thousands of records to aid us in our decision making and generating the forecast. As Smart Predict is business focused, it's very important that the results are understandable. Here we can already see the top produced data slices with the lowest mean average percentage error, and also the bottom that might be less trustworthy. Each individual slice can be inspected to see what the forecast values are and how they relate to the actuals. So we can see that a trend seems to have been spotted, and we could even ask for further explanations to understand what type of cycle and trends have been discovered. So there seems to be a non-linear trend, and there is a quarterly trend or cycle that we can follow. After reviewing these different data slices, the end user can choose to publish and write back all of these individual forecast items to our model. So clicking Save Forecast, I'm able to save it into my private version called Smart Predict that I've just created. And by clicking Save, I'm writing the results back directly into my model. As you can see, the results have been written back into the model and the Smart Predict version as you would expect. Further changes, adjustments and allocations can still be applied. It is important to note that current iterations of Smart Predict were continuously improving the algorithm to take into account the latest changes, making sure that it takes into account new trends and cycles as they have occurred in the COVID crisis. Furthermore, we're also writing back results from, for example, mean average percentage error, so that the user in the story can review the results to see if they're trustworthy enough, again aiding in the business insight to business decision process. In addition to the Smart Predict capability of time series forecasting, which we've previously seen, we also have regression and classification capabilities within SAP Analytics Cloud. To demonstrate this, we will use the EquiRatings use case. EquiRatings is the company that enables users to predict horse performance in a number of eventing disciplines, such as dressage, cross-country and show jumping, and was most recently showcased in this year's Tokyo Olympics. In our first example, we used the dressage use case to demonstrate the regression function. What we see here is a single score. In dressage, the lower the better. These figures are generated from a regression model, where we can initially see the baseline, which is common for all riders, but we've added a new feature to export the key influencers for viewing by the end user. So what is influencing the score is presented in a very understandable way that could easily be used, for example, by an Olympic team selector to understand why a score is lower or higher, and ultimately who they will take to the Olympics. Looking behind the scenes and deeper into the model, we can see the same key influencers and understand how they came about. Again, we see the building of the model is business driven, and we can delve deeper into each key influencer to learn a lot more. Moving to our classification use case, here we are looking at the probability that a horse will clear a given obstacle. Again, we have a single score indicated by 76.4%. We can also cycle through each of the athletes to see their score and also get details of what is influencing each score. Again, looking into the model building interface, we can take a look at the model quality and again go deeper into our key influencers. As you can see, we have a business-driven interface to allow the user to focus on what they want to predict, and then we can output it back to our dataset for usage by our Olympic trainer. Search to Insight is SAP Analytics Cloud native capability to perform natural language queries. The user need not decide beforehand where their data may reside. The natural language query can directly be performed from the home screen without selecting measures, dimensions, or models first, so the user can jump right in and ask their question. From the query, the user can then decide to make subsequent queries for the first measure based on a specific model. As you can see here, we are presented with the top 5 closest matches. So once the model is selected, we now have the gross margin, and we can ask follow-up questions using natural language such as this year, in Germany. So the 2 questions in one using natural language dissecting 2 dimensions. Going a little further, we can break down our question by product. As you can see, the visualization is interactive as any other within SAP Analytics Cloud. We can also add additional comparisons, and as we type, we are given recommendations. Search to Insight will always propose the most appropriate chart for the question. Should you wish to change this, you can always define the visualization types, for example here, heat map. From here, the user could easily ask all kinds of other questions. For example, sales revenue by sales manager. Again, the adequate visualization type is chosen. And I can also focus my selections by asking to see the top 5 and by adding a time dimension to my question. It generates an interactive time series chart where I can select the time periods I'm most interested in. It's important to note here that all this functionality using natural language query is supported also on live data, meaning you can directly query your trusted and governed data sources. Furthermore, it is also supported on mobile devices. Expanding this functionality allows you to use speech that you can then use to generate natural language queries. To enhance the capabilities of the already quite rich natural language generator that we have, you can also add synonyms. Here you see general synonyms that the business users might use in everyday communication, and in some cases these may be very specific to your business. You can maintain them individually or en masse by uploading them into the tool. All these functionalities are meant to democratize the use of analytics to a wider audience. For example, a dashboard builder doesn't necessarily need to be someone skilled at building dashboards. For self-service use cases, you can use the same Search to Insight functionality we saw before, where I'm creating my dashboard, I can ask my questions, and once happy with the result, here I can copy each visualization and paste them onto my canvas, allowing business users to build their own dashboards using natural language queries. Next, we're going to talk about Analytics Content Catalog. This is a catalog where users can add metadata for a completely searchable experience for both SAP Analytics Cloud content, but also non-SAP Analytics Cloud content. On the Catalog tab, we can see a faceted view where we can see all of the cards that contain content. By opening one of these cards, we can see details such as images and text. We can also see within the Business Purpose tab the newly added rich text format. We have a direct link to the content. Details on how metrics are calculated can also be added. Tags can be used either predefined or added by users to make the content searchable. One of the key elements of the catalogue is that it's workflow driven, meaning the catalogue remains up to date using the workflow between users and administrators. As mentioned, external content can also be saved in the content catalogue. As with SAP Analytics Cloud content, the content is searchable and can benefit from some of the same rich text formatting and metadata as content on SAP Analytics Cloud. This content can be based on any type of platform, so long as it is accessible by a link. The content catalogue is highly searchable. This can be done by using predefined filters created through the workflow. Here we can have an inclusive filter focusing on Africa and the year 2020. In addition, all the text is searchable. For example, if I'm interested in daily metrics, I can add this to the search and I will now see content featuring Africa in 2020, which has daily metrics. As well as being searchable, the content on the content catalogue is also highly collaborative, using the standard interface in SAP Analytics Cloud, where from any place within the product, we can always launch the collaboration panel. We can then get in contact with our colleagues. We can post stories to colleagues individually or to groups. with active links and further our conversation. Furthermore, on the Today page, certain files can be featured by administrators to be pushed to the end user. To conclude this presentation on the catalogue, it is good to finally note that you can also see the number of views, number of tags, and favoured content at any time. New functionality, as mentioned earlier, is that you can now, as an end user, request access to content, and the administrator will get a workflow request to give you access to that content, which you may not have had access to, expanding the space of insights that you could potentially reach. For smart recommendations, we refer back to the prior presentation on Search to Insight. We're not on a content level, but on a data level. Users can get smart recommendations on potential follow-up questions, or here we can see recommendations for potential new search that could be interesting. SAP Analytics Cloud has a wide variety of collaboration services. Starting with the discussion panel, we can see how 2 or more users can be included for discussion across the story. Within the group of users, you can as well add story links, task processes, as well as attachments within this group for effective collaboration. With a wide area of commenting service opportunities for SAP Analytics Cloud, let's begin with the widget comment, in which you can add comments to each and every visualization and tables in your story pages. These comments are visible to everyone who has access to this story. You can also add contextual comments to individual cells in a table. Comments to other users are shown contextually based on their viewing context, taking into account the different filter combinations available within the story. We call this data point commenting. We also have the newly introduced commenting widgets. You can add this widget to your page where it will live and always be visible, showing the different comments inputted by various different users. Finally, we note that this shows comments contextually and takes into account the different filters selected about story and page level. These contextual comments, either on a data point or in the commenting widget, are powerful in that they provide an overall narrative to the data to value process. Furthermore, they provide context looking back at decisions as a form of audit trail to help us understand why specific decisions might have been taken in the past. The SAP Analytics Cloud platform offers out-of-the-box system monitoring, where we can check the number of licenses used and applied, system uses by storage, and system usage by users. There is also a detailed activity log where we can find all error or other activities that we would like to monitor. On top of these detailed logs, they can also be assessed by shipped analytical content through the content network, where we can see usage on a number of pages. For example, here we have the overview page where we can jump right into the back-end statistics to see what is causing potential performance hiccups, or where users might be facing issues. Furthermore, we can have back-end analysis where we can find the root cause of potential problems, individual queries, and what users are doing. Front-end statistics to see if there are bottlenecks in our front end where we can make changes or reach out to users that might be facing issues. And the same with front-end analysis, where we can easily jump back and forth between periods, even looking at issues happening today. All of this allows SAP Analytics Cloud users and administrators tightly monitor performance on the back end and front end using a detailed source, as well as being able to use detailed analysis on top of the shipped content through the content network. On top of standard monitoring functionality and analytical content shipped with SAP Analytics Cloud to monitor overall platform performance, there are a multitude of other ways that we could ensure the best possible performance. One way this is done is by providing in-app best practice guidance for story designers when creating analytical content. To view this, we will go to Edit mode. directly see potential warnings of where we could optimize performance, providing best practices. In this example, we could reduce process-heavy widgets on a single page. Furthermore, we get a warning in the filter line where we could potentially improve performance because the filter line will be reloaded regularly, and we could potentially collapse the filter to improve performance. These are just some of the examples on how we provide in-app guidance and design recommendations to story creators, so they can build performant analytic content and be mindful of the end user while designing the content. In this short demonstration, we're going to take a look at the Lifecycle Management workflow in SAP Analytics Cloud via the Content Network. Users can create a package and define the content that needs to be transported, for example, from a development to a production tenant. Users can choose required objects and the system will automatically identify any potential dependencies. Here I will create such an export. Firstly, I create a new one. Choose the objects that I'd like to transport. Note here that I'm choosing a single story and the associated objects or dependencies will automatically be added to my export. I will need to define a name and a description. I will then need to define the destination or multiple destinations of the tenant. In the final step, I can review the items that I'll be exporting with all the individual dependencies noted. And finally, by clicking Export, I will open it up for export, which will then be conducted in a background job. On the destination tenant, I can import the objects I've just shared with the Content Network. Clicking Import, I see the export job that I just created. Clicking the job will show me all of the objects associated due to the fact that every object is associated with unique IDs in the background, allowing me to update or overwrite data and objects using the import job. Because this tenant already contains the objects here, choosing this selection would overwrite all of the objects in here. I do not want to overwrite, I just want to update what is not yet present, and clicking import over here will again launch a background job importing the files that I've chosen to export. Doing so concludes the demonstration about the wealth of capabilities that lifecycle management between tenants is offered through the SAP Analytics Cloud platform and the Content Network. In SAP Analytics Cloud, there are multiple ways for an end user to promote their content to a wider audience. For example, if I go to the folder with promotable content, an end user is able to open, for example, a story, and within that story, they're able to directly share this using the collaboration panel, thus making a story available also to the other users. Going back to my files, I can also choose to take all of the content that's within this folder and move it to a public folder, making it available for everyone that has access to a folder within the public folder. Finally, it is also possible to take content from the promotable content folder as it's public and position it on the content catalog. For this, we refer you to the video on Content Catalog, where we can show how content can be shared using a workflow, and also access to content can be both requested and granted via this workflow. To conclude the topic of promotability, it is important to note and refer to the other video on lifecycle management, as content, of course, can be also promoted from a test tenant to a production tenant, thus promoting the content to the subsequent environment, taking into account unique IDs to make sure that there is thorough lifecycle management flow in place. SAP Analytics Cloud has the capability to add dynamic text to stories. This text can, for example, be used as a watermark. In this example, illustrated by the Maintain by Q watermark, Watermark should instill trust in end users, illustrating this example. By showing the watermark only if the content has last been edited by someone of a given team that is trusted to govern this content. Now switching users in edit mode, you'll note that I am now using a user that is not in the MQ team. So you'll notice that the watermark has changed into a dynamic text that is indicating that this user isn't a member of Gartner MQ and has last updated it. Other dynamic text like last updated will remain intact. This way, the watermark can be used to instill trust in end users to know that the content that they're looking at is governed by a trusted authority. In SAP Analytics Cloud, I can create a story based on multiple datasets. First, I will select a dataset called National Service Park. And then I will switch to the story view and add a chart and select the linked model. From there, I will select another dataset, Best Run Sales dataset. I will now link these two datasets with a common dimension. In this case, I will select the date dimension, but as you can see on my first dataset, the date dimension is calc month. So I get a warning that the level of granularity in my two datasets is different. Going back to my canvas and my builder panel, I can now add my linked model and start to add dimensions and measures to my visualizations from both datasets. First, I will select the backcountry campers measure from the Best Run Sales dataset. And I will then select the units sold measure from the other dataset. From here, I can also add dimensions. In this case, I will select the calc month dimension from my National Park dataset. Now I will also add a filter by range. In this case, I will choose fixed range, and I will choose the year 2019. Now I can see both measures coming from the different datasets on the same chart. I can also drill down by quarter, and here I can see my final results with my two measures coming from my two different datasets. SAP Analytics Cloud has both data wrangling and data modeling capabilities. In SAP Analytics Cloud, you can upload data from a flat file or from a data source. Here I will upload data from a CSV file, and I will select the semicolon separator. The system has automatically detected for each column whether it is a dimension or a measure. I can then see the repetition of my data here, for example, for the Unicode dimension. I can also create a hierarchy. Firstly, I select the region, then the park type, and finally I select the Unicode. I can then see the resulting hierarchy in my panel. I can also create a GEO hierarchy. To do this, I select the United States as my country and the top level of my hierarchy. I then select the state dimension as my region, and again I see my hierarchy result in my panel. I can also validate my dataset, and I can see that the system has detected some errors in my dataset. I can drill into these errors to get more detail, and I can see that I have two errors, AS and VI, which are not states but are in fact territories. To clean the data, we can use a transformation to filter out the American Samoa territories and the Virgin Island territories. We can also use the expression editor to create a new column, combining both year and month. And we can then change the data type of this new column to be a date. Finally, we can see the different transformations that we've performed on our data in the transformation log. You can also create public dimensions in SAP Analytics Cloud. Public dimensions are very useful because they can be reused in different models. We can also set specific authorizations to these dimensions. Public dimensions are searchable within your system, and here we can select the state by region public dimension. For this, there is a hierarchy, and you can assign rights and decide which teams and which users will see a specific node in the hierarchy. You can also create models. Models are basically the combination of measures and dimensions. And here we can see the public dimension we viewed earlier. Models can be reused multiple times to create multiple stories. SAP Analytics Cloud has different impact analysis mechanisms. At the model level, you have a section called Related Objects, where you can see all the different kind of objects that are using this model. So for this model, you have an allocation object, a number of value driver trees, and many stories attached to this model. If I try to delete this model, the system will generate an alert telling me that I can't delete this model because it has many dependent objects. Another impact analysis mechanism is when I delete a dimension from a model. So here I delete the country dimension. I get a warning telling me that my model and my related objects will be impacted by this deletion, but I can still proceed, so I click on Delete. Now I can go to one of the stories using this model. In my story, I can immediately see that one of my charts can no longer be displayed. Going to Edit mode and the Designer panel, I can select my chart. I can see I have a warning telling me that the country dimension cannot be found anymore in my data source. Organizations collect large amounts of data every day. A large portion of it is personal and therefore cannot be used to gain competitive advantage because it would risk breaching an individual's privacy, which would contravene privacy laws. SAP HANA Data Anonymization helps overcome this challenge, enabling you to gain a competitive advantage while securing privacy at the same time. Let's look at data we collected from travel expenses from our employees. This data is obviously sensitive because we see where employees have been and how much money they have spent. The data you see here doesn't contain any name or identifier. However, if I do know certain details, I can start drilling down and find individuals, assuming I know a 19-year-old in our organization that travels frequently. And by selecting that dimension, I can find out where this male person has been and how much money he has spent in certain locations. SAP HANA Data Anonymization is a database tool that enables us to secure privacy of individuals by making sure only a certain group of individuals is presented on the application here in the dashboard. In that sense, it ensures that the number of people, in this case 8, is indistinguishable with respect to age and being a frequent flyer or not. The application does not allow the user to go deeper, for example, on a certain dimension, because it may reveal the identity of the individual, for instance, a 19-year-old frequent flyer, and with that, the privacy of individuals is ensured, and we can build applications on top, allowing us to gain insights about our travels without risking the privacy of individuals. On top of the extensive capabilities seen in modelling so far, SAP Analytics Cloud is natively integrated with the Business Technology Platform. This incorporates a wide variety of data flows and more extensive data modelling and connectivity capabilities to support both SAP and non-SAP data sources. First, we will see modelling capabilities in SAP Data Warehouse Cloud, and subsequently data flows built using SAP Data Intelligence, from which the end result can be consumed live in SAP Analytics Cloud. We will start off with SAP Data Warehouse Cloud Space Management to show connectivity and integration. In Space Management, under the Connections tab, you are able to create new connections to sources which you want to use for modelling. You can choose both SAP and non-SAP sources. After you have connected to your data sources, you can use the Data Builder to perform all the necessary steps for data integration and modelling for graphical view building. In a graphical view, you can combine data from various sources in an easy and comprehensive fashion. So for example, I want to join my sales pipeline with the relevant products. I can do this in just a matter of clicks. After, you can create calculations, or with the use of projection option, you can hide various things from your view. When your data is ready to consume, you can share the data to a central place where other users can integrate your contribution into a central model. In the Business Builder, all the different entities are now available, and in the consumption model, it is possible to build multi-fact models. With multi-fact models, we can make use of all the association and links which are already done in the data layer. And the multi-fact models are ready to consume in SAP Analytics Cloud. With the space management in SAP Data Warehouse Cloud, it is possible to organize modeling tasks into smaller pieces. So in each space, teams or assigned users can create objects and contribute them to a central model, to a central space. When you enter one of these spaces, you have the possibility to create objects like views, which are the basic building blocks for the entities you can use in a global semantic model. The sharing capabilities of the space concept helps you to share the objects within the spaces from a local to a central space. After you've shared these objects in a central space, you can model upon these objects to different dimensions, analytical data sets, and also the consumption models which are using the different entities. Intelligent Lookup in SAP Data Warehouse Cloud helps you when you're trying to bring together data that doesn't quite match up. So let's take an example. I have Google Analytics data from my website, where on given dates visitors came and clicked, and this happened in certain places in the world. But I want to know which continents this is happening in, and I want to make a map out of that. So to do this, I will need another data set. I get a data set for all the cities of the world, which says their continent, their longitude, and their latitude. But how do I join these and take care of issues such as spelling differences or translation differences? Well, this is where Intelligent Lookup comes in to help. It lets you formulate a series of rules that follow different math strategies. You can choose to compare data where we have exact matches in certain columns, like for example, here we see city and country. Or where there are fuzzy matchups, we can chain all of the rules together to funnel all the data through, and wherever you have match cases, this is piped to your output, and where it doesn't, you can either take a decision or add another rule, like we did here. Taking a look into one of these rules, we formulate for anything that doesn't quite match on city and country. Let's possibly just be fuzzy on the city. But in order to differentiate between the different Frankfurts that exist in the US and Germany and elsewhere, let's be exact on the country as well. And so through that, I've actually funneled my data through and eventually come out with a data set that is all combined. So I have my dates, I have my cities, and wherever something can be found, it's in. Wherever nothing can be found, it's in one of those rules where we can actually manually adjust things or just literally fill with default values. So now I can directly, after 2 minutes of work, report on this, even though it's not really matching up 100%. And I can always work and adjust these rules as I go. SAP Data Intelligence Cloud has data preparation capabilities with open source approaches. Inside SAP Data Intelligence, you can browse the catalog to search for different data sets. Here, I'm looking at the turbine data sets. I can see that this turbine data set is coming from a data lake. I can also see the visual overviews of different key metrics. We can also go into Jupyter Notebook environment, where I can use, for example, a Python library to create visualizations on top of my data sets. In the modeler environment, you can assemble different standard operators. We can then pull data from the data lake and then run Python scripts to do the data preparation and data modeling. Finally, we can push the data to SAP Analytics Cloud for visualization purposes. Python is not the only language we support from the data processing capabilities. We also support R, Node.js, JavaScript, and C#. The end result in SAP Analytics Cloud is visualization of the various wind turbines, where we are looking at the predicted gear oil temperature as a result of our model versus the actual gear oil temperature, and where there are significant differences between the two. If we drill down to the Gamsbull area, we can see that this area is in red. We can look at this over time and we can see that there's a real divergence between the predictive versus the actual gear oil temperature. The main object type within SAP Analytics Cloud is the story. The story in itself is a highly interactive dashboard or report-like object. This means that all of the visualizations and tables are interactive. You can filter, you can draw, you can even compare the different elements together for variance analysis. You can sift through pages, see all the different types of visualizations, and multiple SAP Analytics Cloud stories can be combined into one coherent presentation. This presentation format in SAP Analytics Cloud is called the Digital Boardroom. Here, multiple SAP Analytics Cloud stories can be navigated into an interface that's meant for board-level presentations. We can sift through the pages in an interactive way, as we saw before with stories, and navigate through the different agenda topics that we might have for that day. Stories can be dragged and dropped into Digital Boardroom format to build a presentation that's needed for a meeting that day. Digital Boardroom functionality is unique to SAP Analytics Cloud. SAP Analytics Cloud is highly visual and highly interactive. To illustrate this, we'll look at the bar chart where we can make some custom selections. By selecting a single bar, note that all the other graphs and geomaps are changing as well. Or I can select multiple bars and the variance is now shown. I can also drill down on a single item, and with all of this, the groups keep on changing. I can do a lasso selection, set the filter, and see my results. The selection is also supported on the geomap, easily focusing on a certain part of the data, but still taking into account my prior selection. Or I can zoom out and look at the full dataset in its entirety again. Furthermore, we have a high level of interactivity in our line chart. Here we've already seen a given variance now in percentages. But imagine now I would like to make a different comparison and I would like to look at the previous month. Now I'm not looking at percentages but in absolute values to see what the difference or variance is with the previous month. Below, we also have a highly interactive time series chart that we can look at the last 6 months, the last 3 months, or a full period. And have an interactive slider to focus on a given period we would like to analyze. These are just some of the examples of how SAP Analytics Cloud is a highly interactive visual interface, where we've created custom groups using filters in different charts and visuals that overlap, creating the group where we can zoom in to a certain slice of the data, but also zoom out to get the full picture. Adding variances is also a possibility here, and in other videos we show the smart functionality where we get smart insights or a smart forecast directly from the visual that you might be viewing at that point in time. All these actions aid in the business user in getting insight from the data and turning that insight into an actual action in the applications in SAP. SAP Analytics Cloud as standard boasts a wealth of visualization capabilities, including bar charts, geomaps, line charts, including variances, and also to be expanded with functionality like, for example, trellis. Here we can see in the designer that we can add a number of capabilities like a reference line, variance, trellis, tooltip, hyperlinks, and cross calculations. Trellis in this visualization has been added, meaning that now for each material group, or in this example, we see a separate line chart. On top of standard visualizations, visualizations in SAP Analytics Cloud can be expanded using the R engine or adding custom widgets in the Analytics Designer. In this example, we see a Sankey diagram fully interactive with standard functionality, like for example here at the filter bar. But utilizing a specific Sankey diagram element that's supported by the R engine, looking here at the number of registrations by region, which I can see as a measure and a dimension coming from the SAP Analytics Cloud system. This means that SAP Analytics Cloud, on top of its standard visualizations, can offer virtually any type of visualization a business user could like or need for their use case within the same platform. In this example, we see a GEO map and a table indicating the movement of packages from location to location. Using the R widget with a network chart on the bottom right, we are provided with insights we would not otherwise be able to see easily. In this example, we see that a package in the flow gets to its destination, but it actually went back and forth, impossible to see on the GEO map and hard to quickly read in the table. Even more complex cases make the use of this interactive network chart even clearer. This shows the power of the extensibility of SAP Analytics Cloud using R widgets. SAP Analytics Cloud has geocoding capabilities. Within a story, you can quickly create a geomap. First, you choose a layer. In this case, we choose the chloropleth layer. We add the dimension. You can also change the color palette. Here I've switched to the red-green palette. You can zoom in and zoom out, and you can select and drill into a country. Here I'm drilling into India. Once I've done that, I can change the level of my hierarchy, and I can navigate through it to the sub-region level. And I can zoom, in this case, to the west coast of India, for instance. There are different ways to interact with GeoMap. For instance, I can do a lasso selection, add the filter to my selection, and the charts linked to the geomap are also filtered. I can also do a lasso selection on my bar chart, and the filter is also applied to my geomap. I can also switch to another layer, in this case a bubble layer that includes more than 1,000 data points. If I zoom on the East Coast, I can see the cluster change, and eventually the actual data points are visible. Another interesting feature in HANA Geospatial that SAP Analytics Cloud leverages is distance filtering. So here we have bike events and bike shops. There are my customers and my bike lanes, and we're based in San Francisco. I can ask HANA Geospatial to filter out bike lanes that are over a given distance from bike shops, for example over 1.9 kilometers. If I zoom in on Golden Gate Park, I can see the traffic on bike lanes. This is represented by the different colours. These lanes are actually custom shapes. Uploading custom shapes to HANA is a very common use case. Perhaps more common use case for using custom shapes is to represent custom sales regions. It is also used a lot in the utilities in the transport industries to display things like networks, pipelines, and roadways. In SAP Analytics Cloud, we can use external chart libraries. Here we're using an eChart library. We select the chart and use the code to create a custom widget in SAP Analytics Cloud. To use this custom widget, we first need to import the custom widget created previously into our system. Then you can add the custom widget into the SAP Analytics Cloud application. And the custom widget will behave like any other widget in your application. In an application, you could have multiple custom widgets, potentially coming from different external chart libraries. And this custom widget can be linked to different SAP Analytics Cloud datasets. To extend the data visualization capabilities of SAP Analytics Cloud, shapes, images, and interactive elements can be added to make the story more visually appealing. In this example, we have an interactive stock ticker, some text elements, and we also see isotype SVG elements that can be colored in any way the user would like. These elements are part of standard functionality that can be added using the base library of SAP, or subsequent elements can be loaded in SVG format to be colored in a way the user would like for the story or infographic. Furthermore, GIFs are supported as well as colouring in different shapes and sizes. All of these functions aim to make the story more visually appealing or aid in the creation of infographics. In SAP Analytics Cloud, you now have access to reporting capabilities, so by default, the table is scrollable. You can also switch to paginated view of your table by activating a new option. By doing so, you create some pixel-perfect reports. And what you can also see is that the page header and the table header are repeated in each page to keep you oriented. Another interesting feature is the relative positioning. If I expand my hierarchy in my table, you can see that the chart below is repositioned automatically, so it is displayed correctly with no overlap. This year we introduced sections, where we can now create sections which focus on a particular dimension within a report. For each dimension, all subcharts in the section are filtered for that member, and with the vanishing toolbar, I can navigate through the different sections for each dimension member. Finally, you can also export your report in different formats, for example PDF or PowerPoint. Here I have chosen PDF and I can specify the range of pages I want to export. And I can also insert an appendix at the end of the PDF document. So the export is done in PDF and you can see the different pages displayed, and finally the appendix at the end of my PDF document. In SAP Analytics Cloud, users can select prompts to filter their reports if prompts have been defined on the original data source. These can be viewed within your SAP Analytics Cloud story, and you can start to filter your report. So here, for example, I will change the date filter on my story, and I'm going to choose the 1st of January 2019. Click OK and set the new prompt value. Here you can see that all my charts are now updated so that the table chart and my two charts below are updated with the date I entered of January 2019. Then I can also again open my prompt dialog and change a few of the values. Firstly, I'm going to select my distribution channel, and I'm going to select the agent member. I click on Set, and now again all my three charts are updated in real time. If you want to know which prompt values have been applied to your report, you can select the filter option and you can see the currency has been set to Euro. And we can also see in the change that we just made that the distribution channel is set to agent. We can see the same applies in all the other charts. SAP Analytics Cloud is an enterprise analytics solution which allows you to schedule your reports. You can schedule your report based on contextual filters, so let's see how to schedule a report. Firstly, we design a start date. Then we can set how frequently we want to send the report. We can next choose whether we want the output to be PDF or PowerPoint. We can add text, and we can also include a link to a story. In the distribution section, you can share different views of your stories with different recipients. So in this case, I will create a first view called Large Customer Group, and I will choose to share it with the team and a user. Note, you can also choose non-SAP Analytics Cloud recipients. For my story view, I will select my Large Customer Group bookmark. And finally, for my PDF, I will decide to only share the first and second pages. I will then add another view, and this time I will call it Specialty Customer Group. I will choose a different team and a different user. And for this view, I will select the Specialty Customer Group bookmark. For the file settings, I will choose to share the first 3 pages and also insert an appendix. Once complete, I can create my schedule. Let's take a look at the emails we receive. I have 2 emails based on contextual filters, one on large customer group and another one on specialty customer group. In my email, I have a PDF attachment, message content, and a story link. In my PDF, I have all the selected pages for my large customer group. In my second email, I have a very similar result, but this time the first 3 pages and appendix for the specialty customer group are shown.